हॅलो स्टुडंट, वेलकम टू अवर चॅनल महाराष्ट्र मीडिया. मी गायत्री सदाफळ तुमचं पुन्हा एकदा स्वागत करते आपल्या यूट्यूब चॅनलवर महाराष्ट्र मीडियावर. ओके, सो तुम्ही अजूनही आमच्या चॅनलला सबस्क्राईब केलं नसेल तर सबस्क्राईब करा आणि साईडला दिलेलं बेल आयकॉनला प्रेस. ओके, सो लेट स्टार्ट. आज आपण स्टार्ट करणार आहोत क्लास 10 सायन्स सोल्युशन पार्ट फर्स्ट, चॅप्टर नंबर 7 लेन्सेस. सी द क्वेश्चन नंबर फर्स्ट. मॅच द कॉलम्स इन द फॉलोइंग टेबल अँड एक्सप्लेन दे. ओके, see the answers here. Farsightedness, that is a faraway object, can be seen clearly. Okay, lenses are convex lens. Presbyopia, that is a problems of old age. Bifocal lens. Nearsightedness, that is a near object can be seen clearly, that is a convex lens. Farsightedness, hypermetropia or farsightedness is the defect of a vision in which a human eye can see the distinct object clearly but is unable to see nearby object clearly. In this case, the image of the nearby object will fall behind the retina instead of an retina. Okay, possible reasons for hypermetropia. First point, curvature of a cornea and the eye lenses decreases, hence the converging power of the eye lenses become less. Second point, the distance between the eye lens and the retina decreases and the focal length of the eye lens become very large due to the flattening of eyeball. The distance between the eye lens and retina decreases and the focal length of the eye lens become very large due to the flattening of the eyeball. See the diagram here. Okay, so second is the presbyopia. Presbyopia is the defect of vision in which the aged people find it difficult to see nearby object comfortably and clearly without spectacles. Okay, spectacles. Reason of presbyopia. The power of accommodation of eye usually decreases with the aging. The muscles near the eye lenses lose their ability to change the focal length of the lens. Therefore, the near point of eye lenses shift rather from eye. This defect is corrected using a convex lens of the appropriate power. The lens converge light rays before they fall on the eye lens such that the action of the eye lens forms the image on the retina. Third point, nearsightedness. Myopia or nearsightedness is the defect of vision in which a human eye can see nearby object distinctly but is unable to see distinct object clearly as they appear indistinct. In this case, the image of the distant object is formed in the front of the retina instead of the retina. Okay, possible reasons for myopia. First reason, the curvature of a cornea and the eye lenses increases. The muscles near the lens cannot relax so that the converging power of lens remains large. The distance between the eye lens and the retina increases as the eyeball elongates. Myopia is corrected using a suitable concave lens. Light rays are diverged by a concave lens before they strike the eye lens. A concave lens of the proper focal length is chosen to produce the required divergence. Hence, after the converging action of the eye lens, the image is formed in the retina. See the diagrams here for myopia. Question number 2, draw a figure explaining the various terms related to the lens. Answer. First is the center of curvature. The center of the spheres whose part from the surfaces of lens are called as the center of curvature of the lens. A lens has two centers of curvature, C1 and C2, two spherical surfaces. Second point, radii of curvature. The radii of the spheres whose part from the surfaces of the lens are called as a radii of curvature of the lens. Third point, principal axis. The imaginary straight line passing through the two centers of curvature of lens is called as a principal axis of the lens. Fourth point, optical center. The point inside the lens on the principal axis, though through which light rays pass without changing their path, is called as optical center of the lens. Fifth point, principal focus. When a light rays parallel to the principal axis are incident on the convex lens, they converge at the point on the principal axis. The point is called as a principal focus of the convex lens. Light rays traveling parallel to the principal axis of the concave lens diverge after refraction in such a way that they appear to be coming out of a point on the principal axis. This point is called as a principal focus of the concave lens. A lens has two principal foci, f1 and f2. 6 point, Focal length f. The distance between the optical center and the principal focus of lens is called as a focal length f. Okay, of the lens. C1, C2 centers of the curvature. R1 and R2 are the radii of curvature. O is the optical center. The cross section of convex and the concave lenses are shown in the parts A and B of figure 7.4. The surface mark as a 1 is a part of the sphere S1, while the surface mark as 2 part of the S2. See the diagram. Here also given that P1, P2, P3 are the incident ray of the light, and Q1, Q2, Q3 are the refractive rays of light. O is the optical center. See again one diagram. Diagram consists of F1 and F2 principal foci of the lens. F is the focal length of the lens. Okay, question number 3. At which position will you keep an object in front of the convex lens so as to get a real image of the size as the object? Draw the figure. See the diagram here. Question number 4. Give a scientific reason. In A simple microscope is used for the watch repairs. Answer. First point. When an object is placed within the focal length of the magnifying glass or the simple microscope, it's larger and the erect image is obtained on the same side of the lens as that of the object. Second, by adjusting the distance between the object and the lens, the image can be obtained at the minimum distance of the distinct vision. Thus, a watch repair can see the minute parts of watch more clearly with aid of a magnifying glass than with the naked eyes without any stress on the eye. Hence, watch repairs use the magnifying glass while repairing the watches. Question B. One can sense colors only in the bright light. First point. The retina in the eye is made up of many light sensitive cells. The rod-shaped cells respond to the intensity of light, while the cone-shaped jets respond to the various color. Second point. The cone-shaped cells do not respond to the faint light. They function only in a bright light. Hence, one can sense color only in bright light. C. We cannot clearly see an object kept at the distance less than 25 cm from the eye. Answer. First point. When we try to see the nearby object, the eye lenses becomes more rounded and its focal length decreases. Then a clear image of the object is formed on the retina of the eye. Second point. The focal length of the eye lenses cannot be decreases beyond some limit. Therefore, we cannot clearly see the object kept at the distance less than 25 cm from the eye. Question number 5. Explain the working of an astronomical telescope using the refraction of light. Answer. Construction of the refractive telescope. It consists of two convex lenses called as objective lens and the eyepiece. The focal length and the diameter of the objective lens are respectively greater than the focal length and the diameter of the eyepiece. The objective lens is fitted at the one end of a long metal tube. Second, a metal tube of a smaller diameter is fitted in this metal tube and the eyepiece is fitted at the outer end of the smaller tube. With the help of a screw, it is possible to change the distance between the eyepiece and the objective lens by sliding the tube fitted with the eyepiece. The principal axis of the objective lens and the eyepiece are along the same line. A telescope is usually mounted on the stand. See the diagram here. Working. When the objective lens is pointed towards the distinct object to be observed, the rays of the light from the distant object, which are almost parallel to each other, pass through the objective lens. The objective lens collects the maximum amount of light. As it is large in size, it forms a real inverted and diminished image in the focal plane of the objective lens. Now, the position of the eyepiece is adjusted such that this image falls just within the focal length of the eyepiece and serves as the object for the eyepiece, which work as a simple microscope. The final image is slightly magnified virtual on the same side as that of the object and inverted with respect to the original object. The final image can be observed by keeping the eye close to the eyepiece. If the image formed by the objective lens lies in the focal plane of the eyepiece, in final image is formed at infinity. Question number 6. Distinguish between the following. A. Farsightedness, okay, and nearsightedness. Answer. Farsightedness. In hypermetropia, the human eye can see a distinct distance distinctly but unable to see a nearby object clearly. Second point, in this case the image of the nearby object will be formed behind the retina. Third point, this effect can be corrected using the convex lens of the appropriate power. Nearsightedness. First point, in myopia a human eye can see near object distinctly but is unable to see distant object clearly. Second point, in this case the image of the distant object is formed in front of retina. Third point, this defect can be corrected using the concave lens of appropriate power. B point, concave lens and convex lens. Answer, concave lens. First point, a concave lens has its surface curved inwards. Second point, it is thicker at the edges than the middle. Third point, it can form only a virtual image. Fourth point, it can form only a diminished image. Convex lens. First point, the convex lens has its surface puffed up toward outwards. Second, it is thicker in the middle than at the edges. Third point, it can form a real images as well as a% virtual images. Fourth point, it can form a magnified, diminished or the same size images. Question number 7. What is the function of the iris and the muscles connected to the lens in the human eye? Answer, when the incident light is very bright, the muscles of the iris stretch to reduce the size of the pupil. When the incident light is dim, the muscles of the iris relax to increase the size of the pupil. Thus, the iris controls the size of the pupil and thereby regulates the amount of light entering the eye. When a distant object is to be observed, the ciliary muscles relax so that the eye lens become flat. This increases the focal length of the lens, therefore sharp image of the distant object is formed on the retina. Thus we can see a distant object clearly. See the diagram of that formation of an image distant object. Okay. When an object closer to the eye is to be observed, the ciliary muscles contracting increasing the curvature of the eye lenses. The eye lens therefore become rounded. This decreases the focal length of the lens. Therefore, the sharp image of the nearby object is formed on the retina. Thus, we can see a nearby object clearly here. Okay, formation of an image of a nearby object. Question number 8. Solve the following examples. In that first example, doctor has prescribed a lenses having a power eye power which is equal to eye power plus 1.5 d. What will be the focal length of the lenses? What is the type of the lens and what must be the defect of vision? Solution. Data. P is equal to plus 1.5 d. F is equal to what? Focal length of the lenses F is equal to 1p which is equal to 11.5 d, and see the 50 meter which is equal to 0.6667 meter which is equal to 0.67 meter. P is a positive. This shows that the lenses is a convex. The defect of the vision is the farsightedness. Okay, hypermetropia. Second point. 5 cm height object is placed at the distance of the 25 cm from a converging lenses of focal length of 10 cm. Determine the position, size and type of the image. Solution. Data. Converging lens F is equal to 10 cm, mu is equal to minus 25 cm, H1 is equal to 5 cm, velocity is equal to what, H2 is equal to what. First, 1 upon F is equal to 1 upon V minus 1 upon mu, therefore 1 upon V is equal to 1 upon F plus 1 upon u. 1 upon V is equal to 1 upon 10 cm plus 1 upon minus 25 cm which is equal to 1 upon 10 cm minus 1 upon 25 cm which is equal to 5 minus 2 upon 50 cm which is equal to 3 by 50 cm. Image distance V is equal to 50 by 3 cm which is equal to 16.67 cm which is equal to 16.7 cm. Second point, H2 upon H1 is equal to V upon U. Therefore, H2 is equal to V upon U into H1. H2 is equal to 50 by 3 cm divided by minus 25 cm into 5 cm which is equal to minus 50 into 5 upon 25 into 3 cm which is equal to minus 10 by 3 cm which is equal to minus 3.33 cm which is equal to minus 3.3 cm. The height of the image is equal to minus 3.3 cm. Therefore, third problem is the image is real inverted and smaller than the object. Then see the third problem. There are 3 lenses having a powers to 2.5 and the 1.7 d are kept touching in a row. What is the total power of the lenses combination? Solution. Data. P1 is equal to twice d, P2 is equal to 2.5D, P3 is equal to 1.7D, P is equal to what? Total power of the lens combination, which is equal to P is equal to P1 plus P2 plus P3, which is equal to 2D plus 2.5D plus 1.7D, which is equal to 6.2D. Fourth, an object keeps 60 cm from the lens, gives a virtual images 20 cm in front of the lenses. What is the focal length of the lenses? It is converging lens or diverging lens. Solution: data is equal to u is equal to minus 60 cm, v is equal to minus 20 cm, f is equal to what? 1 upon f is equal to 1 upon mu minus 1 upon u, which is equal to 1 upon minus 20 cm minus 1 upon minus 60 cm, which is equal to minus in bracket 1 upon 20 cm minus 1 upon 60 cm, which is equal to minus 3 minus 1 upon 60 cm, which is equal to minus 2 upon 60 cm, which is equal to 1 upon 30 cm. The focal length of the lens f is equal to minus 30 cm. As f is a negative, it is a diverging lens. ओके, सो थँक्यू स्टुडंट. पुन्हा भेटूया आपण आपल्या नेक्स्ट व्हिडिओमध्ये. थँक्यू फॉर वॉचिंग. प्लीज लाईक, शेअर अँड सबस्क्राईब द चॅनल.